Hello and welcome to yet another video about Java, where we are going to be tackling the topic of files in Java. How can we access them, how can we write to them, and how exactly does it work for us? Of course, this video is a part of a larger whole, so if this is the first video that you are seeing and you do not know yet the things that are going to be talked about here, so exceptions, tries, and how to actually deal with it, then please head on to the beginning of the playlist, which is in the description of the video. And if it's the first time that you're hearing about Java programming and you want to start a little bit easier, then please head on to the main channel where you can actually see the beginning of the series about Java. Then without further ado, let's go ahead and talk about files. So of course, whenever we are talking about files, then of course we need a proper class to handle it, and thankfully Java already has it. Just a little disclaimer, operation on files are pretty, let's say, dangerous, and that's one thing, and we're going to explore as to exactly why in just a second. And second of all, they are pretty costly, right? So the operation of files, creating new files and accessing the memory on your computer is not something that is very cheap for Java. So this is very important for you to keep in the future. So yeah, without further ado, let's start talking about how to actually handle files. It's pretty straightforward from the level of Java to create a file class that will actually represent a file. So in this case, we're going to be creating a file object with the path of text.txt. So very important thing. Let's talk about paths and what can we actually get here. So first of all, this is a relative path, meaning that it will create a file essentially at almost the same level of the directory where I'm in. So of course, whenever we're talking about files, we need to discern between the two types, right? We've got a file just like this one, like a text file or anything of sorts, and of course we've got directories that are holding a bigger number of files. Going back to the topic of paths, this here is a relative path, but I could be using an absolute path, meaning that it would lead me exactly to this point with the drive where it's at, the entirety of the path, all the folders that are underneath, right? But this is something that I do not recommend to do because there's a high probability if somebody else were to use your code, then it would actually break because they do not have the same absolute path. For example, an absolute path is something that you see over here in the project. And here you can see that it's C drive, DevLaunch folder, inheritance, polyform exceptions files is the project name, right? So it's an absolute path, but this is something that would not work for you if you were to use it on your PC, unless, of course, you've got the same file structure as I do, which I actually doubt that you have. So always, whenever we are talking about files, use relative paths to be sure that everything is working. But yeah, let's then get to the files themselves. So I've created a file right now, and very important thing that I want to just show you is if I run this, just because I have created a class, rather an object of the file class in this specific path, it does not mean that this file will be created if it's non-existent yet. As you can see here, no file was created whatsoever. However, of course, we can create files. And this file class has some very, very nice utilities in there that we can use. One of those is, let's use an if here, file.exists. And this one checks whether this file actually exists. So if this file does not exist, let's print out file does not exist. Of course, you can also put here some files that already exist within your PC. However, in this case, of course, this is a new one that we will be creating. And yeah, the file does not exist, and we can see that on this path, nothing was found. So of course, what we can do now, and what we actually need to do, is create the file, right, for us. So in order to do so, I'm going to let's just use file.create new file, which is going to result in a boolean, and we can see here first that this is marked in red. And why is that? It's because we've got an unhandled IO exception. So now let's just try and surround this with try catch. So let's try creating a new file, and if anything goes wrong, we've got an IO exception. Let's throw new runtime exception. Okay, let's run it now. And as you can see, in the folder, rather in the project structure, I've got text.txt file created, right? It's empty right now, but I know that I can write something into it in just a second. But yeah, as we can see, everything was created. So in order as to not to add as many files as possible, let's just go ahead and add this check that we had before, file exists. So if it doesn't exist, I want it to be created, right? So let's go ahead and do just that. Okay, let's run the code once again. Okay, I would say that this file was not created. Once again, let's try and delete this. Yes, do refactor, and let's check whether it creates a new. Yeah, it does. So yeah, everything is set up properly. So we've got a try, we've got a catch, and let's talk a little bit about what more can we actually do with the file class. Let's see. We've got a bunch of nice checks, right? We've got the file exists that we have just used, whether it's a directory, what's the length of it, can we read, write, and comparing to other files, and getting the paths, and essentially all the operations that we can use on files, right? We can set whether it is an executable, whether it's a read-only file, writable. So essentially, this is all that is related to file operations. But as you can see here, as I go through the list of methods, I can even delete on exit, right? So it means that whenever I'm not accessing the file, I can no longer write to it. Rather, it will be deleted. So that's very nice. But here, as you can see, there is no method that would allow me to actually write within the file or read from the file, right? I can only do some operations like create a file, move stuff around, make a directory out of it, or something else, but nothing that would actually let me write or read from the file. For that, we need some dedicated objects that will allow us to actually do some operations from the file. So in order to do that, we are going to need file writers and file readers. So file writers and file readers are something that is getting the access to the file, like opening a connection that we need to close at one point in time. Because otherwise, for example, if I were to create a code in Java that is running and is actually accessing the file, writing something there, and I were to open it, for example, in IntelliJ, right over here, I would open the text.txt, I would write here test, and then I still had a process over here that would be writing to it, I would have a conflict, right? Because I would have two connections to the same file that are writing there at the same time, if I do not close this resource. So this is a very important thing to remember. Whenever we are reading or writing to a file, we are going to be using a resource called file writer or a file reader that are closable, meaning that we can close them, and we should close them to make sure that the connection is no longer there, which is a manual operation that I'm going to show you in just a second. Let's see. So if I want to write to a file, I need a file writer. Let's call it file writer equals new file writer, and we use the file that we have over here as the basis of our file writer, meaning that this will be the tool that we use to write into the specific file. But as you may recall, in the beginning, I've told that this is actually a very expensive operation. So if we were to be using file writer and we were writing stuff there one at a time, it would mean that if I write a code that is like this, file writer that append text, it would go ahead and it would just create save t, then e, x, and t, and it will actually go one by one, or something very inefficient. So in order to combat that, there is one thing called buffered writer that is using the writer as its argument in the constructor. And the way it works is that there's a buffer underneath that collects the data, and then it inputs it all at once, meaning that there's only a single operation of writing or reading from the file, which is way more efficient than just doing it one by one or manually. So this is very important to remember. Whenever we're talking about file writing or reading, we always want to use a buffered writer. And then at the end of it, at the end of our code that I will write here, so this will be buffered writer that append, and let's here just use lorem ipsum. Let's put this check in the beginning. so that it creates it first, and then just run it, and let's check our text. And nothing really has happened for text.txt. Let's run it again to double check, and as you can see, nothing has really happened. Because what we need to do is we need to actually close this resource. So we need to run file writer close and buffer writer close. Let's try it now. And here we've got an exception, stream closed, because we didn't use the correct ordering of the closing. And here we can see after. So before I didn't close the stream, what happened is that the connection was still open between these two files, and we didn't really run into a situation where the buffered writer was able to actually save stuff up, right? It was just there and it was still open. But if I allow it to close, it means that, okay, all the operations have been done. I can write what I have in my buffer, and I can actually finish up all the operations. So this is the only way that we can actually ensure that everything is working properly. So with that being said, let's go back into main. So we've got buffer writer closed and file writer closed. But here you can see I've run into a bug, I've created an exception, and I need to worry about what goes where, right? So in order to combat this, because people can be forgetful about stuff, about closing the streams and about closing the writers. So in order to combat this, there is this mechanism called try with resources. So what it is, let me just demonstrate it first. Next to the try keyword, I'm going to put the declarations of file writer and buffered writer. And if I do this, here I can see that this is first of all redundant, of course, and then this is redundant. Why is that? Because within the try with resources, anything that I put here will be automatically closed as soon as the code is finished. And why is it also important? Because usually, if we run the try code and we don't, for example, there's an exception here, but I have created buffered writer and file writer before, I didn't get to the buffered writer close method, right? Meaning that it would break, it would still be active as a connection. So if we do it this way, first of all, we are sure that we don't forget about the close method. And second of all, we are sure that if something goes wrong within the try close over here, the try block, then we always get to close this resource. So if I write it like that, and let's say lorem ipsum, let's just use lorem and write it like this. And as you can see, my file has changed in a way that I wanted it to, meaning that I only got lorem, no issues there, everything is working nicely. So very, very important thing, we really do need to close our resources. And the best way to do it is to actually use try with resources and put it over here next to the try keyword. It's a very important thing. The only things that we could be putting over here are classes and objects that actually implement the closable interface. So if we go into file writer with a control left click, then to the output stream writer and into the writer, we can see that it implements closable, meaning that this resource can be closed. If it didn't implement this interface, we wouldn't be able to use it within the try with resources structure. So with that being said, since we already know how to write to a file, let's also learn how to read from the file. So in order to do that, let's just create a new try with resources. And here, instead of a file writer, we are going to be using a file reader. In a very similar fashion that we did for the file writer, right? So we create a new object and we use the file object as a parameter. And once again, we're using buffered reader to make sure that we are not using resources unnecessarily. And then what we need to catch is an IO exception and file not found exception. So this is another exception that we are running into potentially. But file not found exception is inheriting from the IO exception, so we only need IO exception. So with that being said, in order to read from the file and see how it behaves, right, we first need to go bufferedReader.read line. So we can do it in two ways, right? We can read character by character, or we can read by line. And how it works is that if we go with reading by line, the buffered reader will start at the beginning of the file. For example, if I do it this way, it will, if I go ahead and go with the readLine method, it will start here and end here. And if I call the readLine at another time, it will actually start in the new line, meaning that buffered reader knows and remembers where it has finished the last reading of the line, and it will go through to the next one. So now I will be reading through a single line at a time, but what I want to do is to actually, let's try to, since we know that it already exists and we get some content there already, let's focus only on reading from the file. So now let's then try to read through the entirety of our file. And just a spoiler, we are going to be needing a loop to go through all the lines. Also very important about the behavior of the buffered reader, when it runs into the end of the file, it will return a null. So it actually tells us when the file ends. So this is our condition for the code to end. So let's try, and first of all, let's create in our try block a string line that will first equal an empty string, while line is different from null. And now we are going to put here line equals buffered reader read line. And let's print out our line. So the way it works is that, as I've said, when we run into the end of the file, we'll get a null in our line object. And each time we go through this, through our file, we are reading a new line. So let's go ahead and run this code and let's see what it does to us. And we can see that we run into a null at the end of it. So this is working as we have expected. So it means that we go through the entirety of the file and we print out the line. If we want it to be very, very, let's say, diligent in our work, we would put here an if or something else to actually get rid of this null at the end of it. So to sum it up, the operations of files are pretty simple when we're talking about Java and actually very intuitive, right? So first of all, we need to create an object of the file class with the specific path name. But remember, it does not really equate to creating a new file within the project structure. Important thing, always use relative paths. For example, in here is going to be text.txt. Of course, I can also create a directory or anything else that I would want. We can check whether a file exists, we can write to it, etc., using the file class, but we cannot really write to it or read from it. For that, we need file writers and file readers. Next, whenever we are talking about writing or reading from the file, it's a very, very costly operation. So we want to use a buffer for it so that it's easier and lighter for the PC to actually do it. Then, those are closable resources, meaning that they open up a connection to the file and we want to close them. And in order to avoid forgetting about it, we always put those in the try with resources, meaning into something that we start with the try and then in the keyword. Next to the keyword, we open up parentheses and we put the writers over here. Then, whenever we are reading from the file, I would say it's best to use a line-by-line approach. And then always remember to use a proper loop, because if we run to a null within the loop, it means that we have run to the end of the file and we can actually end our loop. So the best condition would be something very similar to this one. With that being said, that's quite a lot of information, and I would like for you to go through some exercises in order to really master how to operate on files. And those exercises are as follows. First, write a method that will print out all files within a directory. Second, write a method that will create a file using a name provided by the user and then save the content written by the user to it. Additionally, create a method that will print out from a given file. And bonus for that is every 4 words input a new line. So very, very fun stuff to do in this particular one. Third, write a method that will check if 2 files are equal. Another hint from me, equals method is not enough on the file class. Because if we go into file class and try to find equals method of it, and we've got quite a few mentions of equals. Here we can see that we are using a compare to file equals 0, and this compare to actually compares the path name, not the content of the file. So very important distinction. And then fourth, write a method that will take in a file path, take the content of this file, invert it, and save to a new file. In case of a success, return true, otherwise return false. And bonus for that would be write tests that will check if created file was successfully inverted. So it means that you need to create a file in your tests that will actually be inverted and check whether after the inversion we get proper values over there. Of course, for all other methods that do not return void, please do create a test as well. If you have any questions, if you want more exercises or would like to read upon this material in a written form, then I invite you to join us at the DevLaunch school group that is also in the description of this video. But with that being said, this is pretty much it about the files. Thank you very much for listening and watching, and see you in the next video.